Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we're going to be learning about prime factorization. So what is prime factorization, you might ask? Well, if you've watched my previous video on the squares, cubes and primes, you should already know what a prime number is. And to factorize something is to break it down into numbers that multiply to create it. So what we'll be doing is we'll be breaking down numbers into the prime numbers that multiply to make it. So let's take a look at an example of that. Now, we have the number 20 on the board, which we'll be breaking down into prime numbers that multiply to make it. If you've done this already in school, you might have seen a technique known as a tree diagram of some sort, where we have branches breaking down the number. I'll show you that right now. So if you think of two numbers that multiply to make 20, you might say 4 multiplied by 5. So the two branches are the number 4 and the number 5. Now the number 5 is a prime number, but the number 4 is not. So we can further break down the number 4 into 2 times 2. Now on the end of each branch we have prime numbers, which we can then multiply together to create 20. So 2 times 2 times 5. So the number 20 can be written down as 2 times 2 times 5. And it can be further simplified into 2 squared, since 2 multiplied by itself is 2 to the power of 2. So this technique of breaking down the number into two numbers that multiply to create it can become very lengthy if done with larger numbers. I'll show you another technique which saves space and will always give us the result of prime factorization in the ascending order of primes, which is what we want in our exams. Okay, if we were to try to break down 156 by using the branching method, it would take up a lot of room on our page, and the prime numbers would be scattered about, and we'd have to then search for the correct order. The technique I'll show you will save both time and space. What we'll do is we're going to do a bust up, like in division or long division, except rather than doing the bust up above the number, we're going to work down the page. So we'll begin by doing this. Now, because the final answers for prime factorization should be in ascending order of primes, we'll start with the lowest prime number, the number 2, and check, does the number 2 go into 156? If you watch my previous video on divisibility rules, you'll know that the answer is yes, because it ends with the number 6. So let's do this division. So how many 2's go into 1? This is 0, we'll carry the 1, and now we'll do 2 into 15, which is 7. With the remainder of 1, which we carry over to the 6. Now we do 2 into 16, which is 8. Now, for the next number, we'll break it down again by checking the number 2. We'll keep dividing by 2 until we can't do it anymore. So, does the number 2 go into 78? Yes, it does, because it ends with an 8. So, let's do the division. 2 into 7 is 3, remainder 1. And 2 into 18 is 9. Now, does the number 2 go into 39? No, it doesn't, because it ends with a 9. So let's try the next prime number, which is the number 3. Does the number 3 go into 39? If you add the digits, you'll know it does. It obeys the rule of the divisibility rule for 3. So 3 into 3 is 1, and 3 into 9 is 3. and we finish with 13. We could break down the number 13, but only into the number 13 multiplied by 1. And there's no point in doing that. The number 1 is not a prime number, and this would just continue forever. So there's no point. So we'll finish here. Now, let's write down our final result. 156 can be written as 2 times 2 times 3 times 13. And because the number 2 appears twice, we'll write down 2 squared, or 2 to the power of 2. So our final answer will look something like this: 2 squared times 3 times 13. Let's try another example. Okay, let's break down the number 1260. Feel free to pause the video and try it for yourself, and then go through it with me now. So, does the number 2 go into this number? Yes, it does. Ends with a 0. So, 2 into 1 is 0. We'll carry the 1. 2 into 12 is 6. 2 into 6 is 3. And 2 into 0 is 0. Now let's try the number 2 again. Because it ends with a 0, we know it will work. 2 into 6 is 3. 2 into 3 is 1. Remainder 1. And 2 into 10 is 5. Now here, you might be tempted to try the number 5 next, because it ends with a 5, and therefore it's in the 5 times table. However, don't skip the number 3. Let's work in ascending order. So check the number 3. 315 does sum to a multiple of 3. 3 plus 1 plus 5 is 9. So the number 9 also means that the number is divisible by 9, which is 3 squared. So we could do the number 3 twice, or we know we can do the number 3 twice more. So 3 goes into 3 once, 0 times into 1, and carry the 1 to get 15. 3 into 15 is 5. And lo and behold, 105 is divisible by 3, add the digits, you get 6. So 3 into 1 doesn't go, 3 into 10 is 3, remainder 1, 3 into 15 is 5. Now, you should recognize the number 35 from your times tables. 3 does not go into it, 5 does, 7 times. So we finish on a prime number at the bottom, so we can write down our final answer. 1260 is made of 2 squared times 3 squared multiplied by 5 multiplied by 7. And that's it. We're done. Now we'll try a exam style question, a bit more challenging. So this question might appear on a non-calculator paper, so there won't be any calculators to assist us. Using our knowledge of prime factorisation, we can work out the square root of this large number, 15,876. It might seem hard, but because we're going to break it down into much smaller prime numbers, we can then work out the answer much easier. So let's do that now. Alright, does the number 2 go into this number? Yes, it does. How do we know? Because it ends with a 6. So now let's do the division. I'll speed things up a bit here. 2 into 15 is 7, remainder 1. 2 into 18 is 9. 2 into 7 is 3, remainder 1. And 2 into 16 is 8. The number 2 will go into this number because it ends in an 8. So let's try it again. 2 into 7 is 3, remainder 1. 2 into 19 is 9, remainder 1. 2 into 13 is 6, remainder 1. And 2 into 18 is 9. Now, this number ends with a 9. 2 will not go in. Now let's try the next number, 3. 3 will go into this number. If you add the digits, you'll see it's a multiple of 9, which means we can do the number 3, and we can definitely do it at least once more. So 3 into 3 is 1, 3 into 9 is 3, 3 into 6 is 2, and 3 into 9 is 3. Now let's try the number 3 again, since the total of the digits is in the 3 times table. 3 into 13 is 4, remainder 1. 3 into 12 is 4, and 3 into 3 is 1. Now this number, 441, if you sum the digits, it is in the 3 times table. You get the number 9, so we can do 3 again and again, because it adds up to 9. We know 9 will go in. Here's our previous lesson on divisibility rules helping us. 3 into 4 is 1, remainder 1. 3 into 14 is 4, remainder 2. And 3 into 21 is 7. This total is in the 3 times table. Let's do 3 again. 3 into 14 is 4, remainder 2. 3 into 27 is 9. And we can recognize 49 as a square number made of 7 times 7. So we'll skip the number 5 and go straight to 7 and 7. So there we have it. We've now broken down the number into its primes. So let's write down 15,876, which is 2 squared multiplied by 3 to the power of 4 multiplied by 7 squared. Now, when doing square roots, we're allowed to square root each of those primes separately, or each of the numbers in the multiplication separately. So, the square root of this number can be written as the square root of 2 squared, which is 2, the square root of 3 to the power of 4, which is 3 squared, and the square root of 7 squared, which is 7. Now we can simplify and evaluate. So 2 multiplied by 3 squared is the number 9. So, using our knowledge of our multiplication tables, we can do this in any order we want. I believe the best order would be to do 9 times 7, which is 63, and then multiply that by 2, which gives us a final answer of 126. So, our final answer for the square root of 15,786 is 126. And here's our full working out. So, if you believe you've learned something new today, please leave a like and a comment and subscribe for more content, and I will see you in the next video. Take care.